Okay, now number 9 from 2.9. Let's take a look at the instructions. And this really is very related to what I said at the end of the last video. The question is, what is the rank of a 5 by 7 matrix whose null space is 3-dimensional? It's going to use that equation. That I mentioned, the one that says the dimension of the column space of A plus the dimension of the null space of A is equal to n. Okay? So they've given us 2 of the 3 numbers. The big question is, what 2 numbers did they give us? Well, let's see. By the way, the rank is the same thing as the dimension of the column space. Okay. So we have a 5 by 7 matrix A. That means we have 5 rows and 7 columns. So it sounds to me like n is 7, because this matrix is going to take vectors in R7 to vectors in R5, essentially. All right? So just to make that a little clearer, this is basically what your matrix looks like. It's a 5 by 7. So in order for the product to exist, you have to have 7 things. So that means that X is in R7. Okay? So that's how I knew it was taking elements in R7 to elements in R5. But it's really just enough to look at the number of columns of matrix A to get the n. So it's got to be 7. Okay? So the right-hand side of that equation is 7. They give us the rank, which is the dimension of the column space, and they say, well, actually, they ask us for the rank. So this is the unknown. We could call it X. But it says the dimension of the null space is 3. So it looks like X is just 4. So the rank of this thing is 4. You just have to solve for the dimension of the column space if they ask you for the rank. In this case, it's 4.